going to call this an educational piece for anybody out there that's looking for maybe a different way to manufacture their plastic parts or their metal parts, or they have an idea that they want to prototype and possibly bring to production. This is a video all about additive manufacturing with James. Hi, this is James Asbhy from Bowman International. They specialise in additive manufacturing. Hiya, James, how are you?
I'm very well, thank you. Thanks for the opportunity for doing the video.
No problem at all. So if we get straight into it, can you give us a 30-second rundown about what Bowman International are all about, please?
Right, Bowman International as a group are originally a bearing company. If any of your people have ever heard of a product called Oilite, we own Oilite as a bearing. We manufacture split bearings, which is where the additive manufacturing comes in. We do bushes, etc. But my particular part is Bowman Additive Production. We produce things additively.
Okay, so what does that mean in terms of the kind of processes that you can offer manufacturing buyers?
We call what we do a manufacturer's or a designer's secret sauce. A secret sauce isn't by itself something brilliant, but if you put it onto something, it lifts the whole design. So we can help you by making things additively that you can't make any other way, but it's a shape or a geometry or a process that you'd like to have, but you can't machine it.
So does that lend itself to prototype work or production work?
Prototype work is what people have normally thought of in additive 3D printing, as it's called. We additively manufacture things. If you look at it, we're a subcontract tool room. We just don't make any swarf.
How would you describe this process in particular?
The process that we use, we came upon because we did an awful lot of research. It took us 3 years to get it right. We use a very fast system called MJF, multi-jet fusion. It's designed by Hewlett-Packard. And as we look at talking to engineering buyers, I think this makes perfect sense. If you think of what we do as not making one at a time, we have a box to play with, and we can put things in that box from one manufacturer, one person, one customer, 10 of the same thing, 1,000 of the same thing, 1,000 different things. But whatever happens, however many things are in the box, to manufacture it, 80 microns in Z takes 10 seconds. So we can do that whole box and have it done, finished and ready to go in 16 hours.
So what sort of components would you say that this particularly lends itself to?
Anything with difficult geometry. You can make things. I've got some props here, I hope you don't mind. You can see it. Yeah. This is a knurled collar, captive on a little joystick, with a very, very fine thread in it. And that thread is consistent. This part wasn't made on the same batch. If you can see, it's actually hollow inside. It has a mating hemisphere, and it also has a mating thread. So if you look, that was going to be so slick, that screws onto there.
And how long would that have taken to print?
Thousands of these in 16 hours, or I can make 10 of them and 15 of those and 100 of something else and something really complicated like this.
Wow.
The whole build takes 16 hours. What that means is we have a thing called aggregated scale. If you've ever heard of economies of scale, where you make lots and lots and lots of the same thing and the price goes down, what happens with us with aggregated scale is we can make lots and lots and lots of different things for different people, but everybody gets the benefit of economies of scale.
Going into a bit about Bowman themselves, what sort of clients do you like to bring on board? Would you say, what sort of industries do you work with?
Well, we work with virtually anyone, from people who make military drones, people who make footbeds for orthotics, people who make vibro descaling machines. You know, we're an engineering company. Like I say, we're a jobbing tool room. If it's made of, we can make it in plastic, and it fits inside the box, we'll print it.
Do you ever find that companies come to you and say, hey, look, I've been making this widget out of stainless steel for so long, I'd like to turn it into a plastic part, please?
Absolutely. We have an awful lot of people using acetal and Delrin and things like that, or even metals, because they've always used metals, and the drawing may be X years old and it's got acetal on it, basically because people couldn't be bothered to think about any other plastic. It was the only one available at the time. On another note, plastics are a little bit of a dirty word at times because of recyclability. The one we use is nylon 911. You can look it up. 911, exactly the same as anybody else's 911, but it's made of castor oil. It's a renewable product, so it says actually green.
I mean, is there any particular project that you would say that you are proud of?
There's one that we're particularly proud of, where we worked with a company absolutely at their beginnings. They were designing a drone, but their designing was based around normal machining, normal methods, making a clip with a boss and a hole and a thread and a screw and a spring and a clip. Whereas we said, well, you can design that as one part. You can actually make, the silly thing is, complexity in additive manufacturing is not only free, it's cheaper. Now that is absolutely counter to everything I learned. By trade, I'm a tool maker. I trained at a small engineering company you may have heard of, called Rolls-Royce. And one of the things we were always taught is every operation is a prime opportunity to cock it up.
If somebody's got a machined part, would you help with the redesign so that it could be put through your machines, for example?
We can do that. If we can't redesign it ourselves, we know a man who can. The great thing is that the young designers coming out now have all had exposure to additive manufacturing, and they're coming out into industry, and industry is going, additive manufacturing, what's that then? So they all have some design for additive manufacturing experience, and they just don't have the supplier base out there to help them do it.
So James, earlier you said that it's only one operation, and not only is, it can work out to be cheaper. Can you actually show me what this means?
Yeah, we like to think of ourselves as honest brokers. We never try and shoehorn our process into somewhere where it would make no economic or engineering sense. That's no way to keep customers, and it's just dishonest. Can I show you a few props?
Go for it.
This here is a standard top hat bush. We printed it in nylon 11. Now, if you wanted one of those, you'd turn it. If you wanted a lot of them, you would do it on a sliding head. If you wanted 8 of them and you didn't like an apprentice, you'd chuck them a bit of nylon rod and throw them at a lathe. That makes no economic sense or engineering sense to 3D print it. This one is a little more complex. See, it has an infinity oil groove, it's got holes, and all the corners are chamfered. It still makes no sense to additively manufacture that. I would defy anyone in your supplier base to machine that. It has all of the critical faces. There are over 1,000 machining operations needed to do that. And the stupid thing is that one Remember this one here, the simple one?
Mm-hmm.
This one here is half the price of that one and can be made in exactly the same time. This material that we use, nylon 11, it has its limitations. It is as strong as a nylon. It has the temperature. I'm not going to say you're going to overtake metals or anything like that. It's nylon 11, but it's made of castor oil. It's a renewable resource, and the machine that we use actually recycles the powder that we don't use, assays it as being okay, and puts it back in, so there's very little waste.
What's the difference between desktop 3D printing, if you like, and an additive manufacturer?
I would put that back as a question to your audience in what would you look for in a manufacturer of your parts? People look for traceability, repeatability, accuracy, and verification of process. If you don't have those, it's my contention that you're 3D printing. Because we make parts for our own consumption, we make bearing cages for our split bearings, which we patented. Those bearings go into critical situations such as lift shafts, such as mines, such as conveyors, and if they break, the consequences can be dire. So we had to find a way of making things traceable materials, traceable chain of custody of materials and how we store them. Repeatable, everything has to be repeatable from this batch to the next one. Everything has to be accurate. Now, accuracy, we don't get micron accuracy, but we can prove the accuracy that we do. And we verify everything such as process. We verify the materials. We verify the standards. So everything that you would expect from an engineering manufacturer, we have, like I say, we just print things, we don't machine stuff.
It's been a great interview with you today, James.
Thank you.
You know, if anybody's thinking of doing it, pop over to the profile. There's a request a quote button on there, which will go directly to James, or reach out directly to James. All his details are on the profile and they will be linked in the description below as well. So thanks very much, James.
It's been a pleasure. Thank you.